Greetings, ACT fans. Alright, so this is a video on the first packet for ACT Prep, and I'm basically just going to go through the solutions, but try to give you some tips as I go through, as I explained during class. Okay, so let's get started. The first section is pre-algebra, problem set A, and let's look at the first few problems here. Number one is basically a calculator problem. Alright, it's much more accurate if you use your calculator for this kind of problem. Your calculator, especially the graphing calculator TI-30XS2, it does order of operation correctly. So if you type in everything correctly in your calculator, 12 plus 24 divided by 6 times 3 equals, it's going to do everything for you, and it's going to give you an answer of 24. Okay, so definitely you want to use your calculator. You want to minimize the amount of time that you have to work on every problem. Okay, that's very, very key. All right, number two, yeah, you could type that in your calculator as well. It's a lot of parentheses, but some of this stuff is really easy. Okay, so understand, like, it's 3 minus 1, it's 2. All right, why would you type that in your calculator? That's a waste of time. Every second that you waste is seconds at the end that you don't have time to work on the more difficult problems. Okay, so 3 minus 1 is 2, and that cubed is actually not, we're not doing anything with it yet. We're going to say 4 plus 2 is 6. And then you're going to basically do 6 cubed. Now, if you don't know 6 cubed, type in your calculator. You guys probably should know, well, 6 squared is 36 times 6 is going to be bigger than 128, so maybe that even just helps. But if you, obviously, I would just put this right in your calculator from here, and you're going to add 216. Okay? Number three, your calculator has a hard time with mixed fractions. Okay? When you type in, especially the TI-84, all right, to type in 1 3/4, it doesn't let you do that. You can type in 1 plus 3/4, but what I would do if I were you, I would convert this all into improper fractions, then multiply it, and then if you want to hit your fraction button, that's fine. Again, your answer is going to give you, like, 23 over 6, for example. Okay, it's not going to give you a mixed fraction. So let's do that. Remember, you do 1 times 4 is 4, plus 3 is 7. So it's really 7/4 times 4 times 3 is 12, plus 2 is 14 thirds. Alright, now I would definitely do this one in your calculator, and if you do this in your calculator and you don't hit the fraction button, you get 8.167. Okay, 16666. Alright, so obviously these are all out of here. And then you kind of want to check, is that 1/6 is at 0.167, and if you do 1 divided by 6 in your calculator, you see it's 0.167. So this was your answer, is D. Okay? Alright, so the next one, again, you could type in a lot of parentheses, 3 divided by 10 minus 1 divided by 5, but you got to put that whole thing in parentheses after that, and that's a lot of work. Now, if you remember, if you've learned it already, if you multiply this whole thing, the common denominator here, LCD, lowest common denominator, is 10. So if I multiply every term by 10 over 10, alright, what that does for the top, that gives me 3 minus, and then the 5 and the 10 cancel, that's 2. And the bottom, if I do that, I get the 10 and the 5 cancel at 2, so 2 times 2 is 4, and then that's just 30. So I get 1 over 34, which is C. Okay? Much easier than trying to type that whole thing in your calculator. Alright, number 5, what is the percentage equivalent of 0.2184? Now this is tricky, because this is what happens. People get 25% and they say convert that to a decimal. And so of course you move it to 0.25. But what happens is, the reason this is tricky is because you see they're asking you the percent equivalent. So they're not giving you the percent, they're giving you the decimal. Okay, so in order to go from the decimal to the percent, you have to move the decimal over 2 places to the right. Alright, that's really, really important, because people, a lot of times they see, oh, 0.2184, and they go, oh, then I'm going to move it over 0.002184. But that's not true. Okay, this is not what I'm doing. I'm converting this into a percent. So I got to move the decimal to the other way. So it's 21.84%. Okay, which is E. Be careful about that. All right. Number 6 is totally a calculator problem. You type in your calculator, you get 0.875. very fast. That's a 2-second problem. Okay, number 7. When you're solving an equation, you can obviously put the x's together and you move the numbers over. So let me show you 2 ways to do this problem. If you can do this one pretty quickly. I can say basically it's 3 halves minus 1 half is 2 halves, so that's actually, I can combine these two together and I just get x minus 4 equals 1. That's fast. And then add 4, so I'm going to get x equals 5. Alright, that's like really fast. If you wanted, you can multiply, if it was nastier, multiply that whole thing by 2 to get rid of the fractions. That would be another way to attack this one. But this is actually really fast, just to combine those 2 fractions together quickly. Alright, just another tip, math fans. A lot of you guys are taught by all your algebra teachers to show all your work. Like here, just for an example, this step here, you were shown to put a plus 4 underneath each of these. You don't need to do that. Alright, I know you want to do that, but you don't need to do that. You can do a lot of the stuff in your head, don't make a mistake, but you don't have to do all that stuff in your head. Okay, you don't have to write it all out if you know what you're doing. Okay, number 8. This is kind of an example. Why do I need to rewrite it, and then write minus 3k from both sides and plus 3 to both sides? I don't need to do that. If I subtract 3k from both sides, I get 6k, and I add 3 to both sides, I get 18. Okay, and then do I need to draw even this? Do I need to draw a 6 underneath it? No, I can just say, oh, 18 divided by 6 is 3. Oh, the answer is 3. Okay, every second that you save is extra time at the end for the tougher problems. Okay. All right. So now we have practice set B here, and again, just more, just different kinds of problems. This next one, do you really need to type in each one of these in your calculator? I don't think so. Okay, maybe you can write these down. Like 8 to the first power is 8. You should know. If you don't know it, type it in your calculator. It's fine. But 5 to the 0 is 1. And then 3 squared is 9. Okay, so 8 minus 1 is 7. 7 plus 9 is 16. Easy. The numerical order, or the numerical value of this next, again, this is pretty straightforward. 11 to the 0 is 1, plus 11 to the first is 11, plus 11 squared. Again, if you don't know that, put it in your calculator. Okay, so then you add all these up, and you gotta be careful, because sometimes, again, this is not used. People don't think this is used a lot, but it is. It's used at different times here. But anyway, I get 121, 131, 132, 133. That's my answer. And it's not there. So the answer is E. Okay. The common mistake for this one is people think 11 to the 0 power is 0. That's the most common mistake. And that's why you get answer of D. Okay, so be careful about that. All right, this next one, I don't know why you would do anything else but put it in your calculator. You don't need parentheses. Again, your calculator is smart. It does order of operation. So if you put that in your calculator, you get B. Okay. This next one, if 5 over n is an even number, which of the following could be a value of n? All right, so again, if you wanted, you could type in your calculator 5 divided by, and then make sure this is in parentheses. So 1 divided by 5, again, if you type in 1 divided by 5, you would see you get 25. You cursor back over to the problem and type in, oh, let's do 2 divided by 5. Okay? If you do 2 divided by 5, you get 25 halves. So that's one way to do it. What's going to work out is if you do 5 divided by 5 divided by 6, because really it's saying 5 times the reciprocal of that. And if you notice, the 5's cancel, and you just get 6, and that's an even number. Okay, that's why C is the correct answer. Okay. Again, that's a little investigation, being smart about it, understanding that when you do division, you multiply by the reciprocal. So it's basically 5 times, and which one would give you? You can see the 5's going to cancel here. Here you see the 5's cancel, but you get 3 left over, and here the 5's don't cancel. Okay, so D and C are the only ones where the 5's cancel, and then you'll get a nice whole number. Obviously, the other ones don't really work. Okay, but C is the answer for this one. All right, number 5 is actually another good problem. These are really challenging problems. If 4 times 3 to the x is divisible by just 9 positive integers, then x equals. So I tried to think of a clever way to figure this out, but my thought is if I put, let's just test the number out. If I put a 1 in there, I get 4 times 3 is 12. And the numbers that are divisible into 12 are 1, 2, 3, 4, 6, and 12. That's 1, 2, 3. There's 6 numbers. All right, I need 9 positive integers. So I'm just going to go to the next notch. I'm going to say 3 squared is 9. So 4 times 9 is 36. And I'm going to get my numbers for 36. That's 1, 2, 3, 4, 6, 9, 12, and then I kind of work my way up. My next one is going to be 18, and then 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is my answer is B. All right. So maybe what you do is sometimes you start in the middle, and if that's too many, then you work your way back down. If it's not enough, then you work your way back up again. Because by me starting off, I start off in A just to get an idea, and I kind of thought a little bit ahead, and I'm like, oh, let's see, 12. Gee, there are a lot of numbers divisible by 12. Okay, there's 6. Well, it's one more than, it's instead of 6, I need 9, and I went up, said 3 squared, so I did 9 instead of 3. So it's kind of an investigation. Okay. All right, let's go to number 6. Which set of numbers contains only primes? You guys need to remember a prime number is greater than 1, not including 1. So it starts out at 2, and it's a number that can multiply or can divide into itself. The only thing it can divide into itself is the number and 1. That's what a prime number is. So like 2 is a prime number because 2 times 1. 3 is. So if I list a couple of them, 2, 3, 5, 7, 11, 13, 17, those are all prime numbers. 19, okay, but it's greater than 1. So the only one that works for this one is E, because A has got 1 in it, this has got 0 in it, this has got 0 and 1, obviously 9, that's pretty obvious. So the answer is E. Okay. Number 7. In the figure, arcs are drawn above the line every 3 units and below the line every 2 units. If the arcs meet at P and Q, at which of the following points on the number line will the arcs also meet? Well, what you need to think about, this is every 3 for the top, and the bottom is every 2. So that means every 6, even though this one's not drawn here, but every 6, it works. Okay. So what you need to do is you need to divide these numbers by 6 to see which one works. Okay, so divide each one by 6. And the deal is, I know this one's not going to work, and I know this one's not going to work because they're odd numbers, so they're not divisible by 6. So it kind of reduces the number to guess. And if you do the first one, then A actually works. 252 divided by 6 gives you 6. Okay. This one I think is a pretty straightforward problem. Well, if you know factorial. What this exclamation point does, guys, if I said like 3 factorial, that's like saying 3 times 2 times 1. That's all it does. So 5 factorial is 5 times 3 times 2 times 1. It's also, if you, on your graphing calculator, if you hit math and you go PRB, so you cursor over probability, you'll find factorial. Okay, so you can use that. Anyway, what you're going to do is you do everything inside your parentheses first. So 3 times 2 is 6. So it's really 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. You never have to multiply it by 1 because 1 is itself, and you get 720. Okay. Number 9. Basically, you need to remember about perfect squares. Now, this is a common mistake. This is what people will do. They'll go, oh, 9 times 8. I can pull a 9 out of here, and you get 3 root 8, which is right there. But that's not perfectly simplified. You should recognize there's another 2 times 4 there, so I can pull the square root of 4, which is 2. That comes out, and I wind up getting 6 root 2. That's a completely simplified. Okay, because sometimes what people do is they like to just type in the square root of 72 in their calculator and see which one matches. Well, that doesn't necessarily mean that's the right answer because it's not completely simplified. All right, so very, very important that you kind of understand radicals. So that's E. Okay, root 63 divided by which of the following numbers yields a rational number? So basically, I can divide each of these by a radical, and the radical, and I still keep the radical, but let me just show you what the answer to this one is. Root 63 divided by root 7, because what happens is 63 divided by 7 is 9, and that's what they're looking for, root 9, because it uses a rational number. That means nothing under the radical. It's a perfect square, and a perfect square is 9, which then gives you 3 as your answer. So the square root of the answer is square root of 7. Now be careful. This is what happens sometimes. You get this 3, and so you want to put B, because you say, oh, square root of 9 is 3. That's not what they're asking for. They're asking you, what are you going to divide the root 63 by? Same thing, you get root 9, and people want to put that because 63 over 7 is 9, but that's not the answer either. It is, you're dividing it by root 7. Okay? All right, let's keep going here. These are some application problems. What is the average of all multiples of 5 from 5 to 50 inclusive? Now there's there's a way to do this where you're using arithmetic sum and sequence. If you've learned that, the deal is that if I want to find the average, I've got to find how many terms are from 5 to 50. Well, I can count them. 5, I can count on my fingers, 5, 10, 15, 20. You count 10 numbers. Okay? If it's some bigger number, let me just show you the mathematical way to do this. Okay? Okay, before let me use my toes and fingers to do it first, and then we'll do the mathematical. So if I count on my fingers, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, n is 10. So there are 10 numbers. So when I find the average, it's divided by 10. And I'm going to add those together. So if I take my calculator, 5 plus 10 plus 15 plus 20 plus 25, 30, 35, 40, 45, 50, okay, I get 275. And then I divide that out and I get 27.5, which is my answer. All right. So let me show you. Now that was nice because it says 5 to 50, but what if it's 5 to 5,000? Are you going to count that on your toes and fingers? Probably not. So real quickly, let me show you. Those of you who took pre-calculus, you may have had this already. But basically, I want to find the number of terms. So I'm going to go, remember it's a sub n equals a sub 1 plus d times n minus 1. This is going to help me figure out the number of terms. So a sub n is 50, a sub 1 is 5, it goes up by 5 times n minus 1. So I subtract, I get 45 equals 5 n minus 1, divide by 5. N minus 1 equals 9, n equals 10. Okay, there we go, got 10. Now I want to find the sum of those numbers. So if you guys remember, it's s sub n equals a sub 1 plus a sub n over 2 times the number of terms. Okay? So the first term is 5, the last term is 50 over 2 times 10. Okay? So basically I get 55 divided by 2 is 27. 27 times 10 is 275. Now that's the sum. Well, what am I going to do next? Of course, I'm just going to divide by 10 because it's the average. So I kind of just negated that. But it's okay. I found the sum of all the terms is 275, and then I want to find the average of those. So I divide by 10, and I get 27.5. That's definitely the long way to go. I don't think I'd spend that much time, especially if I saw it was a relatively simple problem. I think I would just, I would go quickly and, count fast. All right? Okay, number 2. A race car driver averages 159 miles per hour for 19 laps. How fast must he go on his 20th lap to attain an average of 160 miles per hour? So here's the deal. I'm finding the average of all his laps. So I know I'm going to divide by 20. Okay? Well, for 159 of them, I truly would say 159 plus 159 plus 159. I do that 19 times plus something on my 20th lap. So I'm going to call that X. So here's the deal. It's 159, and I do that 19 times, and then plus one more term is 20, and that's got to equal 160. So I'm going to, if I'm going to find the average of 159 miles per hour 19 times, plus one more time, divided by 20, that's got to equal 60. Anyway, I multiply both sides. I'm going to cross multiply basically, and so I get 159 times 19 is 3021, plus x equals 20 times 160 is 3200, and subtract 3021, so x equals 179. Okay, so that's my answer. All right, not an easy problem, but that's what it is. Okay, number 3. In a standard deck of cards, there are 13 cards with hearts, 13 spades, 13 diamonds, 13 clubs. If one card is chosen from a deck at random, what is the probability that it will be a heart or? Now, if you know probability, or means you add them together. So the probability of getting each of these is 13 over, there's 52 total cards, which is 1/4. So the probability of getting a heart or a diamond is 1/4 plus 1/4 is 1/2. So the probability of getting basically a red card out of half black and half red is 1/2. Okay, so we call these mutually exclusive. If you don't know the term, mutually exclusive is they're completely independent of each other. Hearts and diamonds are completely independent. Okay. All right. Number 4. A cookie jar contains 12 chocolate chip cookies, 6 vanilla, 5 raisin, 2 oatmeal. What is the probability of randomly picking a raisin cookie on the first draw? Well, basically you just count up the number of cookies, and a raisin cookie is, there are 5 of those. So 5 over 25 is 1/5. And that's C. Okay, pretty straightforward. Jeff bought a radio for $14.99, earphones for $9.99, and cassette tape, that's an old question, a cassette tape for $7.99, including a sales tax of 6%. It looks like 0.6, but that's just a, oh, that's because my dot was there. 6%, what is the total bill? All right, so basically what you're doing is you're adding all these up. So you're adding $14.99 plus $9.99 plus $7.99 on your calculator, and you get $32.97, and you're multiplying it by 1.06, and you get $34.95. Okay, which is B. And notice these are not in order either. It goes $30.99, $34.95, then it goes back down, down, and back up again. So just be careful about that. Okay. Eric bought a suitcase for $39.95, a garment bag for $79.95, and a attaché case for $24.99. If the sales tax on these items is 6%, how much will the sales tax? They're just asking what the sales tax is. So I add all these up, which is $144.89, and I multiply that by 0.06. I don't want to know what the total cost is. I just want to know what the sales tax is. So you get $869, okay, which is C. Okay, that's not bad. All right, and let's see, number 7. The price of a gallon of number 2 fuel oil went from 64 cents to 68 cents. What is the percent increase? So this is kind of how you do this problem, guys. It's basically 64 cents, and I want to know plus some increase of 64 cents. So I'm going to say X times 0.64 gives me 0.68. So this is the setup. All right, I'm starting at 64 cents, and I want to know how much am I increasing it, what percent am I increasing it to give me 68%. So I'm going to subtract 0.64 from both sides, and I get X times 0.64 equals 0.04, and divide by 0.64. All right, and I get basically 0.0625, which when you move it over, it's 6.25. Okay, and 6.25 is 6 1/4 right there. D. Okay, it's not an easy question, but that's the setup for it. It's you got to start out with a number and how much am I increasing it. So it's plus. Okay. Number 8. Last year Tom earned $160 shoveling snow. This year he earned $120. Compared to his earnings last year, by what percentage does his earnings decrease? So this is decrease now. So it's kind of the same idea. It's 160 minus, so because you're decreasing 160 times x. I want to know what percent decrease, and that equals 120. So I'm going to subtract 160 from both sides. So you get negative 160x equals negative 40, and divide by negative 160, you get x is equal to 0.25. And that's, of course, moving it over, it's 25% decrease. Okay? Betsy's softball team won 47 games, lost 15 games, and tied none. What fractional part of the games did the team win? Okay, so what you need to do is you need to figure out the total number of games. So total number of games is going to be 47 games won. So 47 plus 15 is 62 and tied none. So there are 62 total games. And how many? You won 47. So it's basically 47 over 62. Okay, and that gives you, well, that's the fraction, 47 over 62. All right, number 10. Adam watches television for 3 hours a day and a total of 12 hours on the weekend. What fraction represents the amount of time he spends watching TV? So, the only weird thing about this one is it doesn't necessarily say for a week, but that's what I'm guessing this one is. He watches TV 3 hours a day each day and 12 hours on the weekend. So it's 12 hours on the weekend. So 12 hours for the 2 days plus 3 hours each day, and there are 5 of those days. Okay, so so basically you get 27. All right, and then it says, what fraction does he spend watching TV? Well, here's the deal. A week is 24 hours a day times 7, so there's 168 days, or 168 hours in a week. So 27 divided by 168. If you put your hopefully you put that in your calculator. You hit math, enter to get your fraction button. And if you do that, you get 9 over 56. So it's C. Okay. All right, move up here. Matt saves 20% on a $110 bowling ball, but he must pay 6% sales tax. What is the total amount that he must pay? So here's the deal. It's 110 bucks. You save 20%. That means he's paying 80%. Don't multiply it by 0.2 unless you want to subtract that from 110. All right. But you're basically paying 80% of that. So it's 110 times 0.8, which is 88 bucks, times 1.06, because it's 6% sales tax, and you get 93.28. Okay? So again, think logically what you're doing here. I mean, if you look at this, if you save 20% on a $110 bowling ball and you got to pay 6% tax, I mean, come on, really? You're going to pay $140.80? I mean, this obviously E is always looming because you don't know, but that's, you kind of have to think about it a little bit what you're going to do. Okay. All right. Number 12. In a metropolitan city, an assessed value of a house is 60% of the house's market value, and the property tax is 3.9% of the assessed value. All right. So basically, and then it says, what is the property tax on a house with a market value of $105,000? So what you need to do is you need to figure out the assessed value first. So it's 105,000 times 60%. That gives you 63,000, and then you need to multiply that by 0.039 for 3.9%, and that gives you 24.57. Okay, C. All right, in the 9th grade, 7 of every 10 students is a girl. If there are 200 students in the 9th grade, how many students are girls? Great proportion problem. So 7 out of 10 are girls. And so I'm going to put the 200 because that's 7 out of 10 students, but there are 200 students, and I want to know how many are girls. Okay, so we get 10x is equal to 1400. Divide by 10, x equals 140. There's your answer. Okay. 14. In a factory, 15 out of every 300 light bulbs is defective. At the same rate, if 120 or 1,200 bulbs are tested, how many of them would be defective? So this is really the same idea, it's 15 out of 300 light bulbs tested. So you always put the same number. See, that's 300. That's on the bottom, so that means 1200 goes on the bottom because that's also tested. So tested, tested. And on top is defective, defective. So you cross multiply 300x equals 18,000. Divide by 300x equals 60. Okay? Number 15. If 3/5 of a job can be completed in 6 weeks, how long will it take to complete the entire job working at the same rate? So basically, it's kind of a proportion again, guys. 3/5 of the job takes 6 weeks. How long does it take to complete 1/2 of the job? And that's your x. So it takes. So again, you're putting the same thing on the top and the bottom. That's 6 weeks. And then how many weeks? This is 3/5 of the job. That's 1/2 of the job. So if you cross multiply, you get 3/5 x equals 6, and then multiply by 5/3 and x, so 5/3 for both sides. So x comes out to be 10. So 10 weeks. Okay, good problem. Good problem. These are all proportion problems. Okay, this last one on a map. 2 inches represents 200 miles. How many miles with 7 inches represent? Total proportional problem. So 2 inches represents 200 miles. 7 inches represents x miles. So you get 2x equals 1400 and divide and get x equals 700. 700 miles. Okay, so you see there, basically the last 3 problems are proportion. There's a lot of percent problems on here. Got to know what you're doing with that. It can be tricky, but it's a lot of practice and kind of know what you're doing a little bit. All right, so that's it, math fans. That's it for week 1 packet. So good luck to you on the ACT, and we have several more packets to go. Adios. Goodbye.